welcome back. So now we're into our appendices for this particular lesson, and I just wanted to show you how lines can get broader as a result of the temperature of the star. So all you got to remember is stars are made of gas, and as a gas gets hotter, the molecules start to move faster, because that's the definition of temperature, the average kinetic energy of the molecules. And so if those molecules are moving away from us, then the color that they produce will be shifted towards the red end of the spectrum. And if those molecules are moving towards us, then they're going to be blue shifted. And if they're doing both of them at the same time, which means that some of the molecules are moving away and some are moving towards us, then that means that that line is going to be shifted in both directions, and so it's going to get broader. So that's the explanation for how temperature can affect the width of the lines. In Appendix 4, I said that if you're one of my students, you don't need to worry about this one, because this gets into quantum mechanics, which I really don't want to go into in too much detail. So I'm going to let you read that. Okay, and if you understand it, fine. If you don't, that's fine. But that's the quantum mechanical explanation for why turbulence causes the width of the lines to increase. So let's go to the next one here, appendix number 5. Now this one's pretty easy, I think, to understand. So let's say that you've got a star that's rotating. Well, then that means that part of the star is rotating towards you and part of the star is rotating away from you, so that the light is both coming towards you. What do we call that? Blue shifted. And some of the light is moving away from you. That's red shifted at the same time. So if you have a line and it's being blue shifted, that means it's moving over to here. If it's being red shifted, it's moving over here, and then when you put it all together, you get a fat line. So that one's not too difficult to understand. It's not too difficult for me to understand. Okay, and then you got Appendix 6, which again gets into that quantum mechanics stuff, which you don't need to know it for in this class, but you would learn this if you take modern physics. And it shows how the energy of something, of an atom, is related to its magnetic field. So when a magnetic field acts on an atom, it gives it energy according to this equation. So don't worry about it. But this one, however, you should know, and this just shows that all of the lines in a spectrum will shift towards the blue end of the spectrum if the source of the light is moving towards you, and then if it's moving away from you, all of those lines are going to be shifted to the red end of the spectrum. So I'd like for you to watch this little thing here, this little simulation found at Media Pearson, and then what you can do is change the speed of the object that's emitting the light, and then you can see how the wavelengths will shift either to the red end of the spectrum or the blue end of the spectrum. So go ahead and watch that if you want to. Okay, so in our last segment we will take our quiz.